Bismillahirrahmanirrahim. In this video, I will solve the problem 4.8 from the book Design and Analysis of Experiment by Montgomery. I take the snipe of this problem. A chemist wishes to test the effect of 4 chemical agents. These are over treatment levels that have been shown in the column. On the strength of a particular type of the cloth, this is our response variable whose values are depicted here in this table. Because there might be variability from one pole to another that is used in the cloth, so the chemist decided to use a randomized complete block design with the board of cloth considered as blocks. So here are 5 blocks that are whose data is shown here. So this is the data from the block 1, block 2, 3, 4 and 5. The resulting tensile strength are as follows. Analyze the data from this experiment. So I will perform the analysis in the Minitab software. To save the time, I have entered the data already in the Minitab. So first of all, you will have to write the names of parameters or factors and then the response variable. So I have written the name of my treatment, that is chemical, then the name of the blocking factor, bold, and then tensile strength or just strength. So in order to show you a trick that how you will have to enter the data in a very short time. So first of all, please have a look at for the chemical number 1, we have 5 different bolts, 1, 2, 3, 4, 5. So we have to write 1 for the 5 times. You can see it here, 1, 1, 1 till 5. Then for chemical type 2, we have again the data for the 5 different bolts. So I have written here 2 for the 5 time, likewise 3 for the 5 time and the 4 also. So we have done with, please always done with the data entry of your treatments that has been shown in the column initially, followed by the bolt. So for each of the chemical, 5 different bolt has been used. So just write 1, 2, 3, 4, 5 once and then copy it and then paste it for the 3 more times. Then enter the data row wise, like 73, 68, 74, 71, 67. So you can see it here. So in this way, there will be no chances of the mistake. After entering the data, please cross check it. Once you have entered the data, now the next step is go to stat, then go to ANOVA, GLM general linear model, fit general linear model, click OK, and then select your response variable, that is strength. In the factor, click chemical and then bold, then go to graph. Here select 4M1, click OK, then go to result. Here select the expanded table. Usually the simple table have been selected, but you will have to select expanded table because you will get the percentage contribution of each factor on the response variable in this way. Take OK and then you will get the results. So first of all, you can see it here, chemical has 4 factors that are fixed and the bolt is also fixed and have 5 different levels. Let's go towards the residual analysis. So click on this graph so that you can view it. Now the graph number 1 and the graph number 3, somehow the data is following the normal distributions. However, there's some kind of issue with the normal probability plot, but we assume that the data is found to be normally distributed. If you are very strict to follow the normal distribution, then you will have to do the transformations of your response variable only. By doing so maybe you will get the data to be normalized. The transformations can be done by a lot of techniques, just like exponential, square root, cube, like this. Over second graph of residual versus fitted value. Now in order to understand, first of all, understand what the positive residuals. So all of the points that are above this central dashed line, they are positive residuals, and those below this central dashed line are negative residuals. So it seems that the number of positive residuals here and the number of negative residuals are almost equal. So it means that the variation in the data is almost equal. The assumption of homogeneity of the variance has been satisfied. Now this last graph, it is for the residual versus observation order. It seems that there are no cyclic pattern from the start till the end. Further, there are no 5 points continuously going above or going below this central dashed line. So it means that the data not following any multi-collinearity issue. Our assumption has been satisfied. Click here OK. Now go above here, model summary. So model summary explains that 82% variation in the tensile strength has been explained by chemical and the bolt. Now the question may arises that R square is 88.63 and R square adjusted is low. Why? Because one of our main treatment, the chemical, is found to be statistically insignificant. So that's why our R square adjusted value has been decreased. If both of the treatments are found to be statistically significant, then you will not observe such a huge difference between these two values. Now, our significance level alpha value or type 1 error is set as 0.05 or 5%. So the p-value associated with the chemical is too high than 0.05. So there is no differences among the 4 different chemical types on the tensile strength. However, the p-value of the bolt is too low than 0.05. So we found that the 5 different bolt types has a significant differences in terms of the tensile strength, and the bolt is found to be a significant factor or parameter or variable. Now, since our main treatment is found to be significant, and so there is no need to perform any post hoc test using Tukey or Fisher. Just you will have to check that which of the chemical is playing its role in order to maximize the tensile strength. So you can do it in 2 ways. The first is go to stat, ANOVA, main effect plot. Here select the response variable strength, select your factors as chemical and bolt, click OK, you will get the graph. And here you can see that the chemical number 4 is increasing the tensile strength. And the bolt number 4 is also increasing the strength. So if you have to select the optimal setting, so chemical number 4 and bolt number 3 are the optimal settings. You can identify the similar settings by going to stat, then ANOVA, GLM. Here you have the factorial plots. So in the factorial plots, you will have to select the response variable, and there are 2 parameter, chemical and bolt. Click OK, and you will get the similar graphs. You can also do the optimization. How? Go to stat, ANOVA, GLM, response optimizer. Here you will have to select maximize the response variable. Nothing else to do. However, this is the setup and then options. So there are no constraint, and you can say constraint to the region. We have 5 different variables. So constraint to the region, click OK. The graphs, we need the optimization plot, click OK, and then wait for the results. Come down. So the solution is that if we use the chemical 4 and bolt number 3, we will maximize our response. Multi-response prediction is doing the same thing, and they are predicting the strength of 76.350, and here is our response optimizer that is showing you this graphically, and our chemical number 4 highlighted in red color and bolt 3 is also found to be the optimal one. Thanks a lot for watching the video. If you have any question, please contact me via WhatsApp or email. Bye.